Imagine you're training a machine learning model to predict whether someone will buy a product, and say that consists of two features: age, which is the range 18 to 70, and salary, which is in the range 20,000 to 200,000. Right off the bat, you can see a scale mismatch. So typical range for age is about 18 to 70. Salary can be this much larger range. So what this means, because salary has a much larger numerical range than age, is that without scaling, the model may incorrectly give more importance to salary just because of its larger values, and not because it's more predictive. So what we should do about this is something called feature scaling. And so what feature scaling is it's the process of transforming input features so that they are on a similar scale or range. And there are two popular techniques for feature scaling. One is normalization, also known as min-max scaling. The other is standardization, known as z-score scaling. And essentially, normalization, you end up with some values between 0 and 1. And with standardization, you have values that center around a mean, usually within the range of something like -3 to 3. So let's look at these more in depth. Specifically, let's look at their equations. So once again, normalization has features in the range of 0 to 1, and we get there from taking the value, subtracting the minimum from it, and dividing it by the difference in the max and min. And then for standardization, we have the value minus the mean and divide it by the standard deviation. So let's give some examples where we have our scalars here. So you can easily use these by using the scikit-learn Python library, where you have the min-max scalar or normalization and the standard scalar or standardization. And here we have our data. So we have an age column and a salary column with very different scales in numbers. And so what we do here is we normalize 0 to 1 with the min-max scalar. We fit and transform on our data. And then we do the same thing with the standard scalar. And then we can compare the two outputs here. So this one right here is our normalization, which we can see it's all between the values of 0 and 1. And in standardization, everything is between the value here of like -1.2 or so up to 1.3. So to sum up, basically feature scaling is needed when you have features with very different ranges, like age and salary. I'm using algorithms based on distance or gradients. And of course, you want faster and more stable convergence. I want to thank you for liking and subscribing. Check my software and courses in the description. Take it easy.